Welcome back to another video. This will be regarding MeshLab and how you can decimate models and also check the quality of the output. So I received the following comment. We see over here. So Arbaz is working on a project that involves some spike structures and he's trying to remesh them into quads. However, we see that there are some issues with the structures that are breaking apart during the process. Now, this was a comment to my video regarding Blender and also Instant Mesh regarding mesh decimation and how you can convert triangles to quads. But let's see, this will be regarding MeshLab. So you can download MeshLab, as you can see over here on meshlab.net. I also put the link in the video description. And we said this is an open source system for processing anything 3D triangular meshes. Now, we see over here that he tries to remesh them into quads. So I would suggest to initially use MeshLab, and only afterwards, when the model is finished, you will go and have that converted into quads. Now, for the case study model, I will use this. So we see the skull over here. This is from Artec. I also put the 3D model in the video description. And I will use this since we have these elements on the horn of the skull, as we can see over here. And we're going to see how during the decimation process, we're still going to keep some of those details. Now, within MeshLab, after you install this, we will go to File, Import and find that file, which will be this one. And I will download and import the WRL file. This will be the initial mesh that we are going to use to compare the decimated one. I'm just going to import this model again. So I'm just going to import it a second time. So you're going to see over here within the project those two models. I'm also going to rename this. So rename current mesh. I'm going to call this for the label decimated. And the first one will be the initial one. Over here we can also change the color within the viewport. This is mostly for visualization. So I'll go over here to color. I will set this to be user defined. And I will choose a lighter color, for example, this green. And now this will be the initial one, which will have that white color. And this will be the one that will be decimated. So this will be set to green. Now, in order to process this, we're going to go to Filter. Afterwards, Remeshing, Simplification and Reconstruction. And since this mesh doesn't have any texture, we are going to go for Simplification, Quadric Edge Collapse Decimation. And we see over here that this is based on an algorithm from Garland and Hegbert. We see the proceedings from SIGGRAPH 97. This will simplify the mesh using a quadric-based edge collapse strategy. Now, I will enable that. We can specify the target number of faces. For example, in this case, I will reduce this by quite a lot. So I go to 25,000. It's important over here to preserve the boundary of the mesh. And also, we're going to check preserve topology because we want to keep the overall topology of the mesh similar within the decimated one. And also click preserve normal over here. And I will hit apply. And you're going to see how this has been processed. And it's currently being processed. Okay, so we have the model finished. So this is the initial mesh, as you can see over here. For example, over here on the eye socket. And if I will display the other one, we're gonna see the decimated one. But over here on top, where we have the details of the horns, we're gonna see all those geometries. So if I will just enable that as well. We're gonna see how the remesh model tries to keep that. So even though I will rotate over here, we're gonna see that the overall shape, so the topology of the model, has remained over here. So this is the remesh one, and this is the original one. So we said there are some deviations because we have a smaller amount of vertices that define that, but overall we have kept that topology. Now, if you also want to measure those values, we can do that. If you're gonna go to filter, we're gonna go to sampling, and if you're gonna measure the, we can also use this algorithm over here, but I will go for distance from reference mesh for this one, because this will also give us the minus and maximum values, and as we can see, this will also store within vertex quality, and we can use that to visualize those within a histogram on the model. So I will enable distance from reference mesh. I will set those like this. So the word unit and the percent, I will leave those by default. We see the measured will be the decimated one, so that has been taken properly, and the reference will be the original WLN. So I'll hit apply, and we're gonna see now this has already been computed. So we see the minimum value will be 0.62, and the maximum value will be 0.62. We see also the mean average, 0.03, and this will be the root mean square for that. So this will be 0.1. But we see how fast this has processed, and this has sampled, as we can see, 12,000 vertices. So it sampled all of those decimated vertices. Now, if you want to visualize that within the viewport, we can go to filter, and we're gonna go over here to quality measure and computation, and color creation and processing. So this will be that, and we need to color this by quality. So colorize by vertex quality, because we have those values stored over here. So this will be the filter. We're gonna see those values. So for the maximum value, we have 0.62. We see over here the minimum, maximum, so they're not quite exactly as those, but you can also change them. But they will be quite close, as we see over here, the mean and the root average. I will hit apply like this, and we're gonna see those added to the model. Now, if I will hide that, we're gonna see that this will be the visualization. So keep in mind that where we have red, that will be with a minus, and where we have blue, that will be with a positive. If you also want to visualize the histogram, so we can also better understand the values, we can go to render, and afterwards we're gonna show vertex quality histogram over here. And we're gonna see that the maximum positive value of 0. We have it over here, 52.9, which will be that one, will be colored in dark blue. So as you can see, we have some light blue, but over here, for example, on the eye socket, we're gonna have some darker blue as well over here on the horns. And regarding the minimum, so as you can see over here, this was the minimum and this was the maximum. So yeah, with blue we have maximum, sorry, not minimum, as we can see over here. And regarding that, so this will be close to 0.52, and the maximum value will be over here on the top. But overall, I consider that MeshLab is the best solution to process decimation, especially if you want to analyze those differences between meshes, because we see how well the model has been decimated, and most importantly, the software is free. So Even though Blender is free, Blender is not that specialized on this, so it can also do some decimation, but this will also allow you to calculate those decimation results. Okay, so I hope you enjoy this kind of content. I also stated over here that I will address this within multiple software solutions. In my opinion, MeshLab is the best for this, since this is open source and free. But I'm gonna do that within CATIA and GeoMagick as well, and you're gonna see those differences. Okay, so if you enjoyed this kind of content, consider to check the video that I will add over here on the left side, and I also add a subscribe button to the right. So that's it. Thanks for watching.